23 people. That is the confirmed death toll from this heat wave as of today, July 5th. 23 Americans who woke up last week and never made it through the weekend. And here is what I need you to understand right now, before we get into a single number or a single forecast model. That count is not final. It is almost certainly going to rise. Heat deaths are chronically undercounted in real time. Some coroners do not classify heat as a contributing cause until weeks after the fact. Medical examiners complete their reviews on their own timelines. So when you hear 23, hear it this way. 23 confirmed. The real number is almost certainly higher. And the heat is not finished yet. This is the heat wave that crashed the 4th of July. The heat wave that forced Philadelphia to cancel its Independence Day parade. The one that shut down the Washington Monument because the stone surface was too dangerous to operate around. The one that pushed New York City's Central Park to 100 degrees for the first time in 14 years. The one that set a new all-time temperature record in Atlantic City, New Jersey at 106 degrees on July 4th itself, America's 250th birthday. The one that forced the United States Department of Energy to issue a full emergency alert for the PJM power grid. The largest electrical grid in the country, covering the entire Mid-Atlantic corridor from Virginia to Chicago, and the one that, as of this morning, has killed at least 23 people. I am Arthur. This is Sky Space Lab, and today I am going to walk you through exactly what happened, what the data is showing us right now in real time, and the question I know most of you actually want answered. When does this end? And what does the rest of this summer look like? Because I have something to tell you about that second question that I do not think you are going to hear anywhere else in quite the same way. Let's get into it. Before we go anywhere near the cause, I want to show you the effects. I want you to understand what this heat wave actually did at the ground level, because the numbers alone do not tell the full story. New York City. Thursday, July 3rd. Central Park hits 100 degrees. That temperature tied a record that had been standing since 1966. It was the first triple-digit reading at that location in 14 years. At the same time, Newark, New Jersey, hit 105 degrees, that city's highest temperature since 2001. And at one point during the morning hours of July 3rd, New York had the highest heat index in the entire country. New York City, not Phoenix, not Dallas, not Houston. New York, Washington, D.C. The capital reached 102 degrees Friday, July 4th, surpassing a record that had been standing since 1872. July 4th in Washington, D.C. was the hottest in the city's recorded history. Thursday through Saturday may turn out to be the hottest three-day stretch the capital has experienced since 1930. Philadelphia climbed to near 104 degrees on Friday, with the heat index pushing above 110. The last time either New York or Philadelphia had back-to-back triple-digit days was 2011, and Atlantic City, New Jersey. 106 degrees on July 4th. A new all-time record for the city. Let me show you what that looked like from a humidity perspective, because the raw temperature is only one piece of the picture. The NWS was reporting heat index values, the feels-like temperature that accounts for humidity, of 110 to 113 degrees in Washington, D.C. and Philadelphia. Nashville, Tennessee, hit a heat index of 111 degrees. Chicago and Detroit, even as the dome began to shift, were looking at feels-like temperatures of 100 degrees or higher during peak afternoon hours last week. The NWS's heat risk index, which runs on a scale from 1 to 4, was showing level 4, which is its most extreme category, across the Mid-Atlantic, the Northeast, and parts of the Great Lakes. Level 4 means dangerous conditions that can affect anyone without access to cooling, not just vulnerable populations. And here is what made this event particularly brutal: the overnight temperatures. Louisville, Kentucky, only fell to 79 degrees overnight Tuesday. La Crosse, Wisconsin, tied its all-time warmest overnight low temperature, 81 degrees, a record that dated back to 1872. That most recently happened in the summer of 2012. Dallas dropped to only 81 degrees at its lowest point during the peak of the heat wave. Rockford, Illinois, bottomed out at 77 overnight. Topeka, Kansas at 79. Caribou, Maine, a city in northern Maine, saw its low only fall to 71 degrees. which tied its all-time warmest overnight low in records going back to 1939. These are not temperatures the human body recovers in. When you sleep in a room that is 80 degrees or in a city where the outdoor air never falls below 78, your core body temperature does not fall back to baseline. You go into the next day of extreme heat already physiologically stressed. That cumulative effect, night after night, is the mechanism that turns a heat wave from a miserable experience into a lethal one. And in this event, it ran for 5 to 6 consecutive nights across the worst affected areas. Where are you watching from right now? Drop your city and state in the comments. I want to see who is still sitting in the heat and who is finally starting to feel that first real breath of relief. Now let me give you the full 7-day picture going forward, because this is what you need to know right now as of Sunday, July 5th. Some relief is already beginning to reach the upper Midwest. If you are in Chicago, Detroit, or Minneapolis, the worst days are very likely behind you at this point. Temperatures will still run above normal through Tuesday, July 7th. But the most extreme heat index values, those 110 to 115 degree feels-like readings, should not return to the upper Midwest in the immediate near term. The dome is moving. For the Mid-Atlantic, it is still a different story this morning. Washington, D.C., Baltimore, and Philadelphia are still inside the tail end of this event. If you are in Richmond, Virginia, or Raleigh, North Carolina, do not let your guard down today. Heat advisories remain active. The NWS is still flagging major to extreme heat risk across the southeast coast this morning, Monday, July 6th. This is when meaningful relief pushes into the northeast. Boston should fall back into the upper 80s. New York City is forecast to drop into the low 90s with falling dew points, which after the last 5 days will feel almost refreshing. Philadelphia could see its front arrive by late afternoon Monday. D.C. is still lagging behind. The capital could still hit the low 90s Monday with lingering humidity. Tuesday, July 7th. This is the transition day I am watching most carefully for the Mid-Atlantic. Both the GFS and the Euro are showing a trough pushing southward out of Canada. If the timing holds, Tuesday could see the heat index fall below 100 degrees across the I-95 corridor from Virginia to Connecticut for the first time in nearly a week. I want to be honest. There is some model disagreement on the exact timing of this trough arrival. The Euro has been a little faster, the GFS a little slower, but both models agree on the general progression. Wednesday, July 8th through Thursday, July 9th. The Southeast, Georgia, Alabama, Mississippi, Louisiana, stays hot through midweek. We are talking actual temperatures in the mid to upper 90s with heat indices still touching 100 to 105 in spots. That is not comfortable. But the core of the extreme, historically anomalous heat is going to be lifting off the Northeast and Mid-Atlantic, Friday, July 10th through Sunday, July 12th. Here is where the model guidance gets interesting, and I want to flag something I have been watching in the GFS ensemble and the European ensembles. As the heat dome slides back toward the central and southern plains, there is potential for a trough to push across the northern tier of the country. That trough could open the door for organized severe weather across the northern plains and upper Midwest around July 10th through the 14th. North Dakota, South Dakota, Nebraska, Minnesota, and Iowa, I would keep your weather apps open heading into next weekend. The GFS has been consistently showing organized convective systems in that corridor. The Euro is more conservative on intensity but agrees on the general timing, the plains heat. As that dome slides west, Texas, Oklahoma, and Kansas are going to feel it. Dallas, Oklahoma City, Lubbock, heat indices back in the 100 to 110 degree range are possible in the second week of July. If you are in that part of the country and you felt like you were watching the East Coast event from a distance, your turn in the spotlight may be coming. But wait, I said there was something bigger I needed to tell you. Let's get there. If you subscribe to this channel because you want the real explanation, not just the forecast, but the why behind the what, this is the part of the video you came for. Stick with me. And if you have not subscribed yet, hit that button right now. Because what I am about to walk you through is the deeper story of the rest of this summer. The heat dome that produced this event is technically described as an omega block in the upper atmosphere. The jet stream buckled into a shape that resembles the Greek letter omega, a ridge in the center, troughs on either side. When that configuration locks in, the atmosphere gets stuck. Weather systems cannot propagate through the way they normally would. The heat builds under the dome day after day, and every day the land surface heats up further and radiates that stored heat back into the lower atmosphere at night, which is why the overnight temperatures during this event were so alarmingly warm. Severe Weather Europe's analysis described the 500 millibar geopotential heights during the peak of this event as running 10 to 15 degrees Celsius above normal across the Great Lakes, the Northeast, and into Ontario, Canada. For context, those are the kinds of anomalies associated with historically significant heat events. Not your typical hot week, the kind of event that ends up in the scientific literature. But here is what I want you to understand. This event did not emerge from a vacuum. The NOAA Climate Prediction Center issued an El Niño advisory on June 11th of this year. El Niño conditions are now confirmed in the tropical Pacific, and they are accelerating. The Nino 3.4 index, the primary metric used to track the El Niño Southern Oscillation, climbed from plus 0.48 degrees Celsius above normal in the March through May average, to plus 0.94 in May alone, to plus 1.7 degrees in the latest weekly reading centered on June 17th. That is an extraordinary rate of acceleration. The International Research Institute at Columbia University, IRI, published their June 26th Quick Look. Their full ensemble of 24 dynamical and statistical forecast models now projects an intensifying El Niño event peaking in the fall and early winter period of 2026. 13 of those 24 models indicate a very strong El Niño event, defined as Nino 3.4 anomalies at or above plus 2.0 degrees Celsius. The IRI ensemble shows negligible probability of a return to neutral or La Niña conditions at any point through at least early 2027, and the ECMWF, the European model. Their seasonal forecast ensemble has reached 100% probability of Super El Niño conditions developing by late fall, one signal that is running ahead of the lead-up to either the 1997 to 98 event or the 2015 to 16 event at the same stage in the seasonal cycle. What is driving this acceleration? Severe Weather Europe's long-range analysis, published this week, points to a massive subsurface Kelvin wave propagating eastward beneath the equatorial Pacific. The subsurface temperature anomalies in this wave are running at plus 8 degrees Celsius between 50 and 250 meters depth. For comparison, the 1997 event, the most impactful El Niño of the modern era, was running at a slightly lower anomaly at the same stage of its development. This wave is already beginning to surface. When it fully surfaces, the atmospheric response is going to intensify significantly. Now, the direct connection to what you just lived through. El Niño modifies the jet stream. During a strengthening El Niño summer, the subtropical jet, the high-altitude wind river that runs across the southern United States, becomes enhanced. That enhancement is one of the factors that has been helping to anchor and amplify the ridge structures that produce events like this heat dome. El Niño summers do not guarantee devastating heat waves over the eastern United States. But when you layer a developing Super El Niño on top of an already anomalously warm global baseline, 2024 was the hottest year in recorded history globally, and 2026 is on pace to challenge it. You get an atmosphere that is loaded. Heat dome events can form faster, hold longer, and reach intensities. That would have been statistically improbable 20 or 30 years ago. This is one of the strongest El Niño developments I have seen in terms of the rate of acceleration at this stage of the seasonal cycle. I need you to hear that, not as alarm, as context, because the implications for the rest of this summer, this fall and this winter are significant. World Weather Attribution, the international scientific network that rapidly analyzes the role of climate change in specific weather events, published their attribution analysis on Friday. Their finding, the intensity of this heat wave would have been virtually impossible without the effects of fossil fuel-driven warming. Not less likely. Virtually impossible. That is one of the most direct attribution statements I have seen them publish for a North American heat event. Now let me talk about the infrastructure failure, because I think this is the most underreported dimension of what just happened. The PJM interconnection, the electrical grid serving Pennsylvania, New Jersey, Maryland, Virginia, Ohio, Indiana, Illinois, and several other states. forecasted peak electricity demand of approximately 166,000 megawatts on July 2nd. That would have been a new summer demand record for the grid. The Department of Energy's emergency orders, which took effect late June 30th and remained in force through July 3rd, were designed to bring additional generation capacity online and prevent rolling blackouts. Emergency orders on the power grid over the 4th of July weekend. In the United States, Ramanan Krishnamurthy, Vice President of Energy and Innovation at the University of Houston, told ABC News this week that the grid was stretched to the limit. He noted something that I think deserves more attention. Canada, which the New England grid depends on for imported electricity, was simultaneously experiencing its own heat wave. Canada Day, July 1st, was hit by severe thunderstorms fueled by the heat, leaving tens of thousands of homes in Quebec and Ontario without power. 55,000 Hydro-Quebec and Ontario Hydro customers lost power. So when New England needed to import low-cost electricity from Canada during the peak of the heat wave, Canada did not have a surplus to share. On July 3rd, severe thunderstorms in New Jersey resulted in 250,000 power outages in the middle of a heat wave on Independence Day weekend. Michigan had 14,000 outages Friday morning. More than 19,000 Con Edison customers in the New York metro area were without power Thursday evening. In parts of the Bronx and Queens, Con Edison was already performing voltage reductions, intentionally lowering power delivery to prevent equipment damage, which risks making air conditioners run less efficiently at exactly the moment when people need them most. Then 60,000 customers had already been restored before the storm, but power went back out. This is what happens when you design electrical infrastructure for average summer conditions, and then the atmosphere delivers above-average summer conditions for 6 straight days across more than 200 million people. Let me come back to the death toll, because I do not want that 23 number to disappear into a discussion of weather mechanics. One of the confirmed deaths in this event was a 68-year-old man in Bethel Township, Pennsylvania, Berks County, on July 2nd. He was trimming bushes outside. The temperature was above 100 degrees. He had a heart attack caused by heat exhaustion. The Berks County Coroner's Office confirmed the cause of death to CNN. He was doing yard work. That is all. He was doing the thing millions of Americans do in the summer, not knowing the heat had crossed into the range where normal outdoor exertion becomes a medical emergency. This is how heat kills. Not in dramatic, cinematic circumstances, quietly, in homes with no air conditioning, in apartments where the power went out 3 days ago, in vehicles, during routine activities that become life-threatening when the heat index climbs above 105 degrees and the body's cooling mechanism can no longer keep pace. The CDC's data shows heat-related deaths in the United States have more than doubled since 1999. Since 2020, the CDC has confirmed at least 9,436 heat-related deaths nationally. Annual heat fatalities rose from 1,156 in 2020 to 2,415 in 2023. Heat kills more Americans every single year than tornadoes, hurricanes, floods, and lightning combined. The NWS 10-year average death toll from heat is 273 per year. The second deadliest weather phenomenon, flooding, averages 114 per year. Heat kills more than twice as many people as flooding. And floods are considered one of the most dangerous weather hazards in the country, and the official numbers are undercounts. The 1995 Chicago heat wave? Initial reports put the death toll at around 465 in Chicago alone. NOAA's final analysis put the Midwest-wide toll at over 1,000. The 2012 Mid-Atlantic heat wave ultimately resulted in more than 30 deaths across 4 states. After events of this scale, statisticians run what are called excess mortality analyses, comparing the number of deaths in a given week to the statistical baseline expected for that time of year. Those analyses consistently show that official heat death counts miss a significant portion of the actual toll, because heat is often not listed as a primary cause of death on the death certificate. Even when it was the trigger, we are nowhere near a final accounting on this event. Have you ever been through a multi-day heat wave where the overnight temperatures gave you no relief at all? Where you went to sleep sweating and woke up sweating? Drop your experience in the comments. I am genuinely curious about the geographic range of what people felt during this event. Now I want to take a step back and look at what this summer could look like through the rest of July and into August. Because the El Niño signal in the models is pointing towards something I think most people are underestimating. The IRI Columbia ensemble is projecting, for the July through September period, a high-pressure anomaly developing over the central United States and extending into southern Canada. Think of it as a persistent background warmth, not the sledgehammer of a full omega block, but a favorable environment that makes heat dome episodes more likely to form and more resistant to breaking down when they do severe weather. Europe's analysis of the last 4 Super El Niño events is consistent on this point. During August through October in a strong to very strong El Niño year, the atmospheric pattern over North America tends to favor what they describe as an omega blocking trend, elevated geopotential heights over the central United States. This is not a forecast of a continuous heat wave from July through September. It means the atmosphere is running with the burner on. When a ridge pulses, when a strong high-pressure system builds, it builds faster and holds longer than it would in a neutral or La Niña year. The background state makes each individual event more. The extreme NOAA's El Niño advisory currently projects the event will persist and strengthen through the Northern Hemisphere winter of 2026 to 2027. If the ECMWF ensemble projections verify, and I want to be clear that long-range seasonal forecasts carry real uncertainty, but if they verify, Nino 3.4 anomalies could approach plus 3 degrees Celsius by late fall. That would put this El Niño event in the same historic tier as 1997 to 98, which remains the most consequential El Niño of the modern satellite era. What does a super El Niño mean for the rest of the country? For the Atlantic hurricane season, the news is actually cautiously positive. El Niño increases wind shear across the tropical Atlantic and Caribbean, which suppresses hurricane development. NOAA's May hurricane season forecast projected 8 to 14 named storms, with a 55% chance of a below-normal season. That suppression signal will likely strengthen as El Niño intensifies through the summer. The Gulf and the Gulf Coast may get some reprieve from major tropical threats this fall. For the southern tier of the country, El Niño winters bring a more active storm track across Texas, the Gulf Coast, and the Southeast. More precipitation, potentially more flooding risk, particularly in California and the Pacific Southwest. The monsoon season in New Mexico, Arizona, and southern Colorado may be significantly enhanced. For the Midwest and Great Plains, the second half of summer could bring continued above-normal heat, punctuated by rounds of severe weather when cold fronts and the subtropical jet stream interact with the warm, moisture-rich air mass over the region. The Derecho Corridor, the belt running from the Dakotas down through Iowa, Illinois, and Indiana, is particularly worth watching through July and August. Warm sea surface temperatures in the Gulf combined with the El Niño-enhanced subtropical jet means moisture and instability will remain plentiful. The only question is when the pattern organizes well enough to produce major severe weather outbreaks. Let me slow down right here for a moment, because I want to do something that I do not always have time for in these daily updates. I want to go city by city through the heat index records that fell during this event, because the list is genuinely stunning when you see it laid out in sequence. Thursday, July 3rd. 20 or more locations broke or tied their daily temperature records that single day. Newark, New Jersey, 104 degrees. Philadelphia, 103. Washington, D.C., 102. Boston, 101. Atlantic City, 103. Wilmington, Delaware, 101. New York City's Central Park, 100 degrees. And Caribou, Maine, a city in the far north of Maine, well above the 46th parallel, tied its all-time warmest overnight low at 71 degrees. Caribou, Maine. In July, then Friday, July 4th. More records. Atlantic City reached 105 degrees. Georgetown, Delaware hit 104 degrees. Williamsport, Pennsylvania, a 100. Baltimore's Inner Harbor, 103. Washington National Airport, 102. Raleigh, North Carolina, 101. Nashville, Tennessee, 101. Norfolk, Virginia, 99. Providence, Rhode Island, 98. Elkins, West Virginia, 94. Mansfield, Ohio, 94, then July 4th itself. Atlantic City, 106, a new all-time record for the city. Washington, D.C., 103. Wilmington, Delaware, 102. Baltimore, 102. Richmond, Virginia, 100. I want you to sit with that list for a moment. Providence, Rhode Island, at 98 degrees on the 4th of July. Elkins, West Virginia, at 94 degrees. These are not southern desert cities. These are northeastern and mid-Atlantic cities with building stock, transit infrastructure, and populations that were not designed for repeated exposures to this level of heat. The grid that serves them was not designed for this. The public health response systems were not designed for this. And this is the summer those systems got tested. Now let me explain the atmospheric mechanics of this event a little more specifically, because I think understanding the technical side actually makes the situation feel more real, not less. The heat dome is formed by a blocking high-pressure system in the upper atmosphere, what meteorologists call an upper-level ridge. This ridge is an area of elevated geopotential heights at the 500 millibar pressure level, which sits roughly 18,000 feet above the surface. When that ridge is strong and stationary, the air under it sinks. Sinking air compresses and warms. It prevents clouds from forming. It blocks cool air from pushing in from the north. And because it is a high-pressure system, winds spiral outward away from the center, meaning the hot air mass cannot escape. It just keeps building. During this event, the anomaly at 500 millibars was running 10 to 15 degrees Celsius above normal across the Northeast and Great Lakes. For context, a 2 to 3 degree anomaly is considered notable. 5 to 7 is significant. 10 to 15 is the range associated with multi-decadal record heat events. That is what we just went through. The omega block structure that locked this dome in place is one of the most persistent and difficult patterns to break in the atmosphere. Once it establishes, the troughs on either side of the ridge actually reinforce it. They act like walls that prevent the ridge from migrating east or west the way it would during a normal summer weather pattern. This is why the NWS was forecasting the heat would peak Thursday and Friday, but then hold through the weekend. The dome had no reason to move. Nothing in the large-scale atmospheric pattern was pushing it. What finally began to erode it was a trough approaching from the Pacific Northwest. You can see it in the model guidance as a deep wave in the upper atmosphere pushing in from the west coast. As that trough deepened and moved east, it began to undercut the eastern flank of the ridge, gradually allowing the dome to slide westward. That is the shift we are watching happen right now over this weekend and into next week. And here is the curious thing about that. Updated model runs in the last 24 hours are showing it may be associated with a brief but significant severe weather setup across portions of the northern plains and upper Midwest in the coming week. When you have all this warm, humid air that has been baking under the dome for a week, and you bring a trough with organized wind energy in the mid-levels sweeping across from the west, you get the ingredients for dangerous thunderstorms. I mentioned this earlier, but I want to come back to it more specifically. The GFS ensembles are painting a fairly consistent picture of organized convection across North Dakota, South Dakota, and Nebraska between July 10th and July 12th. If a squall line or mesoscale convective complex develops in that environment, you could be looking at widespread damaging winds in the 60 to 70 mile per hour range, along with large hail and an isolated tornado or two. The atmosphere has been deeply destabilized by a week of exceptional heat. It is loaded. When the trigger arrives, the response could be vigorous. The Euro ensembles are less aggressive on the organized severe weather aspect, but do agree that a significant weather boundary will push across the region next week. I am going to be watching the 12-hour and 6-hour ensemble updates closely Monday and Tuesday for any sign that the severe weather signal is consolidating. If you are in Fargo, Sioux Falls, Rapid City, or Grand Forks, stay weather aware heading into next weekend. This is not a high-confidence forecast yet, but the ingredients are there. Now, there is one more thing I want to address before I wrap today's video, and it is something that the meteorological community has been discussing more openly in recent years, and that I think deserves a direct conversation here. The National Weather Service's current 10-year average death toll from heat is 273 people per year. But that number is almost certainly a significant undercount of the true mortality burden of extreme heat in the United States. Here is why. The official count captures what are called direct heat deaths, cases where heat is listed as the primary cause of death on the death certificate. But heat often kills by triggering or accelerating an underlying medical condition. A person with heart disease who dies of cardiac arrest during a heat wave, the death certificate may say cardiac arrest. A diabetic patient whose condition deteriorates under heat stress, the death certificate may say complications of diabetes. An elderly person who falls because they are disoriented from early heat stroke, the death certificate may say traumatic injury. When epidemiologists run excess mortality analyses at comparing the actual number of deaths in a heat-affected region during a heat wave to the statistical baseline, they consistently find that the true heat-attributable death toll is 3 to 5 times higher than the official direct heat death count. The 1995 Chicago heat wave is the classic example. Official direct heat deaths in Chicago, approximately 465. NOAA's final assessment of excess deaths across the broader Midwest during that event, over 1,000. That is what 23 means in this context. It is the starting point, not the end point. By the time epidemiologists have finished their work on this event, and that work typically takes months, the true excess mortality number will very likely be a multiple of 23. I am not saying that to produce fear. I am saying it because understanding how heat kills and how we count those deaths is part of understanding why heat needs to be taken as seriously as a major hurricane or a tornado outbreak. We would never say a Category 4 hurricane killed 0 people because the official storm surge count was not completed. We should not discount heat mortality the same way. The CDC's Heat and Health Tracker, which monitors emergency room visits for heat-related illness in near real time, reported extremely high rates of heat-related ER visits across the Northeast on Thursday, July 3rd. The precise numbers are still being compiled, but the signal was significant enough for the CDC to publicly characterize it as extremely high. That is the CDC's language, not mine. Each year, roughly 70,000 Americans visit emergency rooms for heat-related illness. 10,000 are hospitalized. Those are background numbers in an average heat year. During an event like this one, a multi-day historically anomalous heat dome affecting more than 200 million people, those baseline numbers get compressed into a few days. The hospitals in Philadelphia, Washington D.C., New York, and Boston were dealing with a surge of heat-related emergency visits at the same time that those cities were running cooling centers at capacity, opening mobile medical vans, and deploying wellness check teams to check on elderly and unhoused residents. This is what a Category 4 level heat event looks like from a public health perspective. And this is the summer in which the Ninyo now developing in the Pacific is going to be amplifying the background conditions that produce these events. One more number I want to leave you with. Since 2019, heat deaths among Black Americans have risen by 30%, 5 times the rate of increase among white Americans. This is from the reporting published this week, examining the public health impact of this event on communities of color in major cities. It reflects decades of policy choices that concentrated lower-income and minority communities in the hottest, least resourced parts of American cities, neighborhoods with less tree canopy, more concrete and asphalt, older building stock with less insulation, and lower rates of air conditioning ownership. When a heat dome like this one settles in, those neighborhoods run hotter than the surrounding areas and have less capacity to cope. Extreme heat is not a single number on a thermometer. It is an event that interacts with every layer of a city's infrastructure, its housing stock, its grid, its emergency response capacity, and its economic inequities. The places that are least prepared to handle it are the places where the most vulnerable people live. That is the full picture of what happened last week. And it is the picture that I think you need to carry into the rest of this summer. There is one dimension of this event I have not yet addressed, and it is going to matter enormously in the coming weeks. The agricultural impact of this sustained heat. The corn crop across the Midwest is entering a critical window right now. We are approaching what agronomists call the pollination and silking stage, the period when corn goes from vegetative growth to reproductive growth. This window typically falls in the first 3 weeks of July across most of the Corn Belt, which covers Iowa, Illinois, Indiana, Ohio, Minnesota, and parts of Nebraska and Missouri. Heat stress during this window is not a minor inconvenience. Temperatures consistently above 95 degrees during the day, combined with overnight lows that do not fall below 70, can directly reduce kernel set. That means fewer kernels per ear. Fewer kernels per ear means lower yield. I am not forecasting a crop disaster today. The data would need to show a sustained alignment of extreme heat precisely during pollination, and the timing of the worst heat relative to the crop development stage varies by region and by the specific maturity of the crop planted. But the USDA crop condition reports for the coming 2 to 3 weeks are going to be worth watching. In past years, major heat events timed to the pollination window have contributed to significant yield reductions across the Corn Belt. The soybean crop is also at risk. Though soybeans are more heat-tolerant than corn and their critical reproductive window comes later, typically mid to late July and into August. If the pattern I described earlier, the persistent above-normal warmth associated with the developing El Nino, holds through the second half of July, then soybeans could also face stress during their own critical period. Why does this matter to a weather audience? Because agriculture is one of the most direct channels through which extreme weather events translate into costs that you feel at the grocery store.
Heat waves that reduce Corn Belt yields show up in corn and soybean prices, which show up in feed costs for livestock, which show up in beef and pork prices, which show up in your food bill.
These are not abstract connections. They are direct traceable causal chains, and they are one of the reasons that every major heat event in summer needs to be tracked not just as a weather story, but as an economic story. Now let me talk about what I expect to see in the model guidance over the next 72 hours, because there are a few things I am watching very specifically. First, the trough timing for the northern plains. The GFS 12-hour ensemble update that posts tonight and tomorrow morning is going to tell me a lot about whether the July 10th to 12th severe weather window is tightening up or still uncertain. If the trough pushes further south and organizes the flow across Nebraska and South Dakota, I would upgrade that severe weather potential from a watch to a genuine concern. Second, the El Nino index readings. The IRI publishes updated ensemble guidance midweek. Given that the most recent weekly Nino 3.4 reading was already at plus 1.7 degrees Celsius and rising rapidly, I want to see whether the latest buoy and Argo float data shows continued acceleration or any sign of the warming rate slowing. The Kelvin wave that Severe Weather Europe described, that plus 8 Celsius subsurface anomaly between 50 and 250 meters, should be surfacing more clearly in the coming weeks. If it surfaces the way the models project, the atmospheric response is going to be significant. Third, I am watching the Mid-Atlantic closely through Tuesday for any surprises in the relief timing. The euro has been running slightly faster than the GFS on the trough arrival. If the trough comes in on the faster euro timeline, D.C. could get meaningful relief by Monday afternoon. If it tracks closer to the GFS solution, D.C. could be sitting in 90-plus heat through Tuesday. That is a 36-hour difference that matters enormously for the people in the hospitals and the cooling centers in that region. And fourth, and this is the one that I think has the most long-range significance, I am watching the upper-level pattern across the Pacific for any indication of how the jet stream is going to evolve heading into the third week of July. If the subtropical jet remains enhanced, which El Nino would support, and if the ridge begins to reconstitute over the central United States after the current trough moves through, we could be setting up for another heat dome event by the third week of July. Not necessarily at this intensity, but in the same category of above normal, potentially dangerous heat. The atmosphere does not take days off during an El Nino summer. Here is something I want to say directly to the viewers who have been following this channel through the spring and early summer. We have been tracking the El Nino development for months. We have been talking about what an accelerating El Nino means for the summer heat pattern, for the Atlantic hurricane season, for the severe weather setup across the plains and Midwest. And one of the things I have been consistent about is this: the background conditions do not create every event, but they tilt the probability. They load the dice. The heat wave that just shattered records across 20 states and killed at least 23 people, that is not simply bad luck. That is a loaded atmosphere delivering on its potential. and the atmosphere is going to remain loaded for a long time. The El Nino signal that is accelerating in the equatorial Pacific right now is not going to peak until the fall, which means the summer has months left in it, and the pattern that produced this event is not going away. I am not going to tell you that every week is going to look like the last one. It will not. There will be cool spells. There will be weeks where the dome breaks and the relief is genuine. But I'm going to tell you this. The windows of opportunity for events like this one are going to be more frequent this summer than in a neutral or La Niña year. And when those windows open, the response from the atmosphere is going to be faster and more intense than what historical averages would predict. That is what it means to live through a super El Niño summer on top of a long-term warming trend. Not a constant disaster, but a tilted playing field, where the extreme end of the probability distribution is closer to the surface than it used to be. Pay attention to this summer. Track the pattern. Know your cooling resources. Know your neighbors who might not have air conditioning or who might lose power and not have a way to tell you. Check on them during heat events. The 23 people who died last week did not die because they ignored the forecast. Many of them died because they were already in a vulnerable situation. No air conditioning, no power, no way to get to a cooling center, or engaging in normal activity at a temperature that was no longer safe. Awareness matters. Community matters. And understanding what is coming matters. Stay with me this summer. I will be here every day, watching the models, tracking the El Niño, flagging the events before they hit. That is what this channel does. Let me close this video with a look at the bigger picture, because I think there is a framing question that this event raises very directly. America has never been more exposed to extreme heat than it is right now. The average number of heat waves that major United States cities experience each year has doubled since the 1980s, according to the federal government's 5th National Climate Assessment. Climate Central's analysis of the 2024 summer found that the average American endured an extra 17 days of what they call risky heat days, hotter than 90% of local historical records because of climate change. Heat stress has more than doubled over the past 40 years, according to NASA's Jet Propulsion Laboratory, and that trend is expected to continue. And yet the infrastructure built to keep people alive during extreme heat, the power grid, the cooling centers, the emergency response systems, was designed for historical conditions that no longer represent reality. I said at the top of this video that this heat wave killed 23 people. I want you to carry that number with you. And I want you to hold it alongside the fact that this is a summer that is going to produce more events like this one. Maybe not with the exact same record-breaking intensity, but in the same category of prolonged, dangerous, abnormal heat. The El Niño is accelerating. The background temperature is elevated. The atmosphere is loaded. The communities that prepared, that opened cooling centers early, that issued emergency orders before the peak, that worked with utilities to prevent blackouts, did better in this event than communities that did not. That is the lesson that matters beyond the forecast. Tomorrow I am watching the latest GFS and Euro runs for the Northern Plains severe weather potential around July 10th. I will also have updated El Niño index readings. The IRI publishes ensemble data this week, and I want to see whether the latest subsurface ocean observations continue to support the super El Niño projection or whether the models begin to moderate. If this breakdown helped you understand not just what happened, but why it happened and what comes next, hit that like button and share this video with someone who is in the middle of this event. The more people who understand this pattern, the better prepared they will be for the rest of this summer. I will see you tomorrow.